A pivotal question for today's conservation biologists is, in the age of the Anthropocene, what's the least amount of land we need to protect in order to conserve the most biodiversity? The gap analysis approach to GIS attempts to answer this question by assessing how much land is already being protected and what species and habitats are being protected, and how much land falls outside of those borders. Basically, where are the gaps in our current protection and where should we focus on next? Caitlin Dempsey of GIS Lounge describes GIS as a modern extension of traditional cartography with two key differences. One, a GIS map allows a user to supply an infinite amount of additional data. And two, GIS allows us to use statistics and analytics to support our arguments. GIS allows us to add different kinds of geospatial data to create data layers. For example, with GIS, we can see a base map of the U.S. We can add a layer which shows us the network of roads across the country. We can also add a layer showing nature conservancy preserves and U.S. national parks. With this information, we could ask how many nature conservancy preserves are located within 10 miles of a national park? Is that distance bisected by any major roads or highways? This question allows us to make predictions about the potential for species migrations between protected areas. GIS allows us to ask important conservation questions of various data sets. Gap analysis uses specific GIS data layers to identify gaps in protection for species and habitat. The first kind of data required is vegetation classification data from satellite imagery or aerial photographs. This tells us about the habitat types in our study area. Second is land ownership data that describes the boundaries, ownership, and protection status of a given area. Third is the wildlife habitat relations data, which describes either habitat preferences or existing species ranges. The USGS has a gap analysis program working state by state to explore how we're protecting threatened and endangered species. Gap analysis invites conservation managers to perform systematic conservation planning based on where species are and what needs protecting. This is achieved by looking at the big picture GIS data, which show where certain habitats are and how much of it is protected. But as they say, the devil is in the details, and there are a lot of details behind those GIS data layers. The data that make up the layers are vital to the accuracy and usefulness of the later analysis. When you combine the three data layers required for gap analysis, the data may represent vastly different timescales. For example, the USGS GAP program uses the National Land Cover Database from 2001 in combination with species data from varying years and the Protected Areas Database published in 2016. The vegetative data is almost 20 years old, and I can hazard a guess that land use changes have taken place in the last 20 years. I'd also like to highlight that the land protection data layer has some plasticity, and that results shown in GIS may not match up with management on the ground. The land protection data is classified in a standard way across gap analysis, where each area is rated on a 1 to 4 scale of protection.
Created using Powtoon.